Hello, everybody. We're at the beginning of week 10. It's pretty crazy how far we've gotten, right? Week 10. It's going to be about logic and decisions. But yeah, just about week 10. Let's see. It's crazy that we're at week 10. Typically at quarter systems, this is the last week. For folks who are transferring to like a university or maybe some other school, there's a chance they might be in the quarter system, meaning that the 10 weeks. Right. Yeah, here we have 16 weeks because we're on the semester system. But yeah, we're pretty much almost done with the course. Uh, we pretty much have to cover some things. One is called logic and decisions, and then next are some looping algorithms. These are probably the densest parts of the course this week and the next couple weeks. It's going to be kind of, I think, dense because the main topic is really control flow. This whole time when we've been writing programs, right, everything before week 10, they were pretty flat programs, right? Like everything up here, flat programs. I mean that every time you run it, you're pretty much gonna get the same behavior, like like in all of these. Our first programming project, Robot Cat, right? You can rerun that, you can get the same behavior. Same with all of these other projects. Right, same behavior meaning that the program doesn't really have certain scenarios to branch off into. So that's the whole goal today. We're going to talk about something called decisions and branching. Okay, so yeah, we're really just going to talk about the if statement today. All right, and some people might be already familiar with the if statement, but towards the later half of class, there's going to be some caveats that that will be some common pitfalls. So stick around. Let me pull up the slides real quick. Refresh. Okay, gonna give a little high-level overview on what the lesson goes over. So once again, we've been writing flat programs, meaning that there's not really a lot of control flow, meaning that our program can't really branch off into different scenarios. So the prerequisite for today will be talking about conditionals. Right? Conditionals are expressions that evaluate to true or false. We've seen this in a lesson all the way in like week 1, right? Long time ago. Week 1, we talked about operators, and there was something called Boolean operations. So here I'll bring up lesson number. Number 4. So this one's on the operators, and if you take a look at the last 5 in this table, all of these are Boolean expressions, right? Meaning that they don't really give us a number, right? Like how in these in the top half, these can give us numbers, like 2 minus 1. This is a mathematical expression that evaluates to a number, but down here, right, 2 less than 3, this is not really it doesn't evaluate to a number, right? It gives us a Boolean, meaning a true or a false. And so that's pretty much the prerequisite for today. I'm gonna do a quick review and then jump into this little slideshow here. So as a quick review, I'm actually gonna pull up a Python REPL. If folks are curious what I'm talking about, this server comes with a terminal, right? So I'm gonna load up this terminal here, and if you type Python into this terminal, Python, and then enter, it's gonna bring us into something called a REPL. This is a command line interface that's interfacing with the Python program, right? So I'm gonna pull up what this is real quick. So REPL, R-E-P-L, stands for read, evaluate, print loop, right? It's a interactive language. In this case, we're using Python REPL, and it's pretty much allows a user to type in single lines and evaluate them quickly. For example, if I were to go into the this terminal right here, right? This is the terminal. You might remember from week 1 we made some variables, right? Like here, let me just make a dummy variable. Like so I'm gonna say here. Let me clear this terminal real quick so it looks cleaner. Oh, whoops, never mind. I can't clear it. Gotta press a keyboard shortcut. So here, remember we said something like, oh, number is equal to 5, right? It doesn't matter. This is creating a variable called number, and it's going to be assigned the number 5. So I'll press enter, right? Nothing shows up, but this is a REPL, meaning that when we type lines into here, it'll evaluate it, right? Like for example, if I were to say number plus 1, right, this is going to evaluate to 6, right? And similarly, if I say number, right, if I just say number only, right, this evaluates to 5, right, because that's how we originally defined it as. Okay, so I do want to point out the differences between the single equals and double equals. If we use a double equals, right, remember back here in the lesson number 4, right? What is this double equals doing? It's comparing for equality, meaning that if I said number is equal to 1, right? This is a Boolean operation. It's saying, hey, is the left side equal to the right side? Right? In this case, it is not, right? So it returns as false, the Boolean. So I do want to point out, right, that there is a big difference between the double equals and the single equals, right? If I were to say number equals 1, right, it might look the same, but it's not, right? This one is doing an assignment. Right? Assignment means it's going to take the right side and set it to the left. Right? So this is not going to give us a Boolean value, right? It's just going to force number to be 1, right? Meaning that if I were to re-evaluate the earlier Boolean, right, this gives us true, right? Because we reassigned it 1. All right, people cool with this so far? So this is Boolean expressions, right? You could say number. Here, let me clear this out real quick. So number is currently. Let me make it a different number. Let me say number is equal to 5, right? We can do more Boolean expressions like, oh, is number equal to 1? No, it's not, right? Because it's 5. And we can do equality stuff, right? We can do inequality, like, oh, is number less than 10? Right? Is 5 less than 10? Yeah, it is. It's true. Right? Is number greater than 10? False. Right? So yeah, no. Yeah, so that's pretty much what we need to know for today. Expressions, Boolean expressions. Okay, cool. There's many things we can do with this stuff. These true and false values can pretty much let us branch into different scenarios. Okay, let's make this a little more concrete. Where's my slides at? Here it is. It's on my other screen. Okay. Cool. Let's talk about the high-level overview of this lesson. All right. I want to bring up a concept called decision trees. You can think of a decision tree as a flow chart that represents the possible scenarios in a program. In this case, the tree starts at the top, right? The top is like the beginning of the program. And then we kind of make some choices based off of certain variables, right? Like if a variable is something, then maybe you branch off into a separate scenario that does another part, right? For example, an example decision tree is COVID. Back in 2020, I had to download an application in order to gain access to some place at UCSC. I think it was the cafeterias actually. So back in UCSC, they had an application that pretty much implemented a decision tree where you would download an application and then answer a couple questions every day, right? And you'd have to do that in order to gain access to the cafeteria. Right, so the application would pretty much say, oh, are you having symptoms? And then you'd pretty much check a box, right? Yes or no, right? So that's a Boolean, right? And depending on that Boolean, we would branch off in different scenarios, right? If you did have, if you didn't have symptoms, then it would branch off into this left box here, meaning that testing is not needed, and you would gain access to the cafeteria. right? But if you said yes, you are having symptoms, then the application would branch off into a different scenario and ask another question, right? It will say, "Oh, are your symptoms severe?" Right, and then you see how there's kind of a sub tree under here, right? It's like a tree within a tree. So yeah, people kind of seeing what I'm saying here, right? You can write programs that branches off into a different scenario, right? In this case, you can think of it as like a access granted or access not granted. Okay, another example of a decision tree that you might have be familiar with are game AI. Right, game AI means that you're programming some sort of bot, like a very simple bot to maybe play a game for you. So a quick example of this, arguably one of the first video games created was Pong. If you want to think about it for a second, imagine that there's like a human and a bot. All right, a bot means the AI that kind of plays for you. How would you program the AI? How would you program the bot? Right, like let's say the player is manually moving the paddle left and right, and then the bot has to think about what to do. Right, how would you do that? Well, you could represent it as a decision tree. Right, you could say, hey, if the ball is to the left of the paddle, move left. Right, if the ball is right of the paddle, then move right. So that's kind of an example of a reflex agent, right? A reflex agent in AI means that they only know like one step ahead. Okay, one more example of a decision tree. This is kind of related to how banks might approve your credit, right? Like for folks who might have applied for a credit card or a credit line, there's typically some conditions that you must meet in order to be approved. For example, maybe you need a high income, or this decision tree is not really that descriptive, but if you've ever applied for a credit, you might have seen a bunch of conditions, right? It doesn't just rely on your income. It relies on a bunch of other things. Okay. Cool. So yeah, that's pretty much today, right? We're gonna be representing programs into kind of like trees for now. There's gonna be some prerequisites like knowing how to write conditions. So we've seen some of these before on week 1, a pretty long time ago. We saw these symbols here. These symbols help us evaluate certain booleans. Right, so examples here, these are just hard-coded numbers right on the right. All of these expressions will evaluate to either true or false. Okay. The theme of today, the tricky part actually for today is kind of visualizing control flow. We're going to be doing this for probably the next 3 weeks. I think this is the tricky part of the computer science classes in general, right? Kind of organizing your thoughts into a formal way. So the first thing we'll see today is an if statement, and I'm going to be showing a bunch of pictures back and forth, so don't worry if you don't catch these pictures in right now, but you can think of an if statement as a fork in the road. Meaning that if a certain condition is true, then the body of it would be run, right? The body is right over here. So this is the first type of control flow we'll see, right? A fork in the road. And then we'll see some more later. I'm going to skim through these really quick, right? Because I'm going to come back to them later. But we're going to see multiple forks in the road, right? Like you can chain if conditions, right? These are actually separate conditions, which means there's separate forks in the road, right? See, there's 2 of them, and you can chain another one, and that's another fork in the road, right? This is kind of combining them. So we'll see this style. And then the part where the control flow gets a little tricky is when we start inserting the else ifs. Right? This will make sense in a bit. But we'll talk about something called else statements. Else means to run it if the earlier one was false. Right? Meaning that this is a a separate fork in that same part of the road. The tricky part comes when we start using else ifs. In Python, they call it elif for else if, which are multiple forks in the road. All right, so here I'll come back to these pictures in just a bit, but that's pretty much the biggest takeaway of today, right? Kind of knowing the difference between all four of these diagrams. But let's go ahead and introduce this first one, this fork in the road, right? At the if statement. So let's go ahead and open up the notebook. Let's see, the notebook we're working with is lesson number 14. And I believe it's paired with a lab 14, which we can probably do concurrently as well. Cool, so I got the lab and the lesson loaded up. Let me go to lesson, here we go. Okay. Cool. So yeah, here's some syntax right here. You can look at this picture. The syntax is pretty much if some condition. Once again, a condition here. This is number equals 5, right? It's either going to be true or false, and if it's true, the body of this will be run. Right? The body, it's indented, by the way. It's very important to indent it if it belongs inside of the branch. Okay, so let's go ahead and do a quick example. This example is going to rely on a variable from a widget. So you don't really have to know too much about widgets, but this first cell will spawn a widget. It's an integer text widget where we can type in any number. And basically we're going to kind of write programs that branch off of this variable here. Right, like let's say I were to type in like 50, right? Our goal is to kind of write some code that looks at this number and decides what to do. Right? For example, maybe we're making like a guessing game. Right? Maybe we're making a guessing game where the user has to guess what the computer is thinking. So in this case, imagine if the computer was thinking 34, right? Just for some reason. In this case, you could make a condition that says, hey, is the widget's value equal to some magic number? Right, so in this case, you can grab the value with number widget.value. This widget has some internal variables, right? This number widget, one of the internal variables is called value, which will give us the number that's inside the box. So you can say, oh, if number widget.value equals 34, right? 34 is just a randomly chosen number. It's like a guessing game, right? In this case, 34 is the correct answer. In practicality, you might want to generate this as some variable instead, right? Like maybe represent a variable that generates a random number. But let's just keep it as hard-coded 34 for now. So here we go. We're writing a fork in the road, right? If the widget value is 34, then maybe we can print correct. Right? This just to give them some feedback. So if I were to press play right now, right, it doesn't print anything, which kind of makes sense, right? Because the widget's value is 50. So what's the value of this condition? Well, what does this condition evaluate to? Evaluates to false. Right? So since it evaluates to false, the body is not being done at all. So this is the fork in the road analogy that I'm talking about. We just did this right here. Let me clean up my screen. Hopefully folks can read this. Yeah, that's what we did, right? If some condition, run the branch, right? So that's the fork in the road. In this case, we didn't hit the fork. We just continued on with the rest of the program, right? Like the rest of the program is down here. Print rest of program, right? Just hypothetically, something else is happening here, right? See, it doesn't hit the fork, but it hits the rest of the program. Okay, and I do want to emphasize the importance of indents. Right? Typically, when you indent, if I were to indent this second print statement, it technically belongs in this branch now. So this can be considered a logical error, because if I were to run it, is not going to print this. Right? It doesn't print this because this is inside of the branch. Okay, so yeah, anyways, people are getting a sense of what I mean by a fork in the road, right? Like what this if condition is representing. Okay, hopefully. Cool, cool. Let's see. Any questions about this so far? Okay, cool. Sounds good. Let's talk about some different conditions that you might find useful. These are examples of Boolean expressions, right? Things that evaluate to true or false. You've seen the inequality one before, right? You can check if numbers are less than, greater than, right? And depending on what it is, you could branch off into different scenarios. You might find this one useful too, actually. You might remember this modulus operator. This is going back to lesson something. Let me see. It's stuff from week 1. All the way in lesson 4, you might have remembered this modulus operation. All right, modulus means it's really just division, right? So it's saying divide, but give us the remainder instead. So this is useful stuff for, see right here, if you want to check if a number is even, right? How do you check if a number is even? Right, you just kind of divide it by 2 and check if there's a remainder, right? That's what this is saying. So like imagine here, I'm going to bring up a REPL, right? Once again, the REPL is just a Python interface. So I'm going to go terminal, type in Python, and just show some examples of this modulus. All right, so let's say I did like 5 modulus 2. Right, this is saying, hey, divide them, but what's the remainder? Right, remainder is 1. All right, well, what about 10 mod 2? Right, what's 10 divided by 2? It's 0, and then remainder, it's 5, and then remainder 0. So that gives us 0. Right, people kind of getting a sense of this. So whenever you mod a number by 2, it's either going to give you 1 or 0. All right, so let's give a harder one. Like here, I just typed in a random number. What's the remainder if I divide this by 2? Remainder is 1, right? Meaning it's an odd number. So people kind of getting a sense on what this modulus is doing, right? It's getting the remainder. A use case for this is for like random number generation. Maybe you wanted to program some sort of 50-50 scenario. Like maybe, let's see. If you wanted to program a 50-50 scenario, you can just generate a random number, right? Like imagine you grab a library, generate a random number, and all you have to do is check if it's divisible by 2, right? This happens to be divisible by 2, so you could do something, and maybe you could generate another random number, and then see if this is divisible by 2. This one is not. All right, so people kind of getting a sense on this, right? You can use the modulus to program to rig certain random number generators. Okay. So this is useful because we can compare it to 0 or 1, right? Like we can say, hey, is a random number odd, right? Well, we just have to mod it by 2 and check if there's a remainder, right? So this is saying, hey, is there a remainder at all, right? No, there is, my bad. There is a remainder when you divide by 2, right? Because this is an odd number. So since there's a remainder, this left side becomes 1. Right? 1 is not equal to 0, so it's false. So yeah, anyways, the point here, going back to the lesson, the point here is you can check if numbers are even just kind of by modding by 2. All right. Here's some more conditions. We can compare for equality with strings as well, right? So we compared equality with numbers earlier. Right? You can do this with strings. Maybe here, let's go back to the REPL. Maybe you can imagine a scenario where there's like a username and a password. Let's stick with the username, right? Like let's say I had a string, I'm just gonna hard code it to like I'm just gonna hard code it to my username, which is antac. Alright, so let's just say a hard coded username, and maybe I was developing some sort of authentication program, right? A program that authenticates if I'm the right person. So you could take advantage of comparing strings, right? You could say, hey, is let's say someone types something, right? Like Bob. You could say, hey, is Bob equal to a username? Right? I'm using two equal sign, by the way, because this is comparing both sides. This is false, right? But then maybe later, let's say Alice comes in and sees if she can be authenticated. In this case, nope, Alice cannot because didn't get the username right. But then later, let's say I come in and I type in my username. In this case, this is true. So maybe the program can branch off into different scenario. All right, so yeah, you can compare strings as well. You can compare strings. Okay. You can also check if strings are inside of strings as well. Like down here, there's this operator called in. Let's see, I think we've touched this very shortly, but in is a Boolean operator that tells us if the left side exists in the right. In this case, we're checking if a string is in a string. So this will kind of let us search words. For example, let's just say my name. All right, I'm just declaring some string to Andrew, and then enter. There it is. I have this will work in your notebook, by the way. I'm just doing it in the REPL because it's a little faster. So you could do stuff like, hey, is Drew in name? Right. Once again, in is a Boolean operation. Does this exist in here? Yeah, it does. Right, it does because this substring right here, right, it says Drew. But we could say, hey, is Bob in name? Right, false, right, because Bob doesn't exist in this string. All right, people kind of seeing what this in operator lets you do. It doesn't. It's not exclusive to strings. It works with, lists as well, right? You can check if an element is inside of a list as well. But this is useful stuff. This is useful for maybe you're making some sort of smart home. Have people here heard of, let's see, like Alexa, maybe Alexa, Amazon? Have people seen this stuff? So this is like a device that listens to what you say, and then depending on what you say, it'll branch off into different scenarios. All right, it's like Alexa, maybe Siri from Apple, maybe Google Home. All right, Google Home, this is also the same device, right? It listens and then branches based off what you say. So you can kind of imagine the use case for this in operator, right? Like let's say there's a voice command, right? For folks who have talked to these things before, right? Let's just say you were to say like Alexa, turn on bedroom light. Right, once again, I'm just hard coding a string, but you can imagine that this is downloaded from the microphone. Right? In practice, this is microphone dot get data or something. But here, voice command, and then you can imagine that the software, right, the program would check if things exist inside of the command. Like it would check if light, right, is light in voice command, right? In this case, it is true, right? So since light is in the command, then maybe the program should branch off into some scenario. Right, so people seeing some use cases here, right? Some pretty cool stuff. I remember a long time ago, I wrote a program. I think this was before Google Home was invented. I'm pretty sure it was. But yeah, before Google Home was invented, I kind of wrote the same thing that kind of controlled things in my bedroom. Right, I had a device. I would talk to it. I would say something like, "Unlock closet door," and then it would unlock it. Or I would say something like, "Turn on oven," or something, and it would turn it on. So it's some pretty cool stuff. Um, okay, let's get back to what we were talking about though. So we were talking about the if statements though. In particular, we're just talking about conditions, right? Things that evaluate to true or false. Okay, I think we have enough to get like 5 questions done in the lab. I think folks should try to do a part of the lab before we move on to the next ones. The next part of this lesson will be introducing more control flow. This one is going to be talking about the else statement. But with what we know so far, just the if statement, we should have enough to get 5 questions done in the lab. So here's the lab right here. Let me double check what we can get done. Let's see, part 1. Okay, we should be able to do the first 5, right? Everything up to number 5. I don't think we have enough to get number 6 done yet. Number 6 is asking us to use an else statement, which we haven't learned yet. You could, excuse me, you could try number 6 out if you want, but at least try to get 1 through 5 done. So here, I'll help folks out with it. The first, make sure you run this first block. This cell right here is setting up some variables for the next cells to work. So make sure to modify these variables, these values, as necessary. For example, instructor, this is a string. Instructor is not Mike. This is actually my coworker. I'm borrowing my coworker's notebook to kind of deliver this class. But the instructor is me, Andrew Tack. Let's see. Current year. I'm just gonna hard code 2025. You know, in practice, you wouldn't hard code this number. You would ask a library to get this for you, right? You would do something like I forget what the library is, but it's like I think it's from the date time library. You'd import this library, and then this would let you kind of generalize this number. I gotta look at the documentation, but I'll just hard code it here. First name, let me hard code Andrew, and then birth year, I'll hard code 1996. That's my birth year. Favorite number, you can put anything here, whatever your favorite number is. Okay, go ahead and press play. This is gonna load the variables into the kernel, which will let you work on the next 5 pieces of this lab. All right, number 1, these are pretty much asking if you can write an if statement, right? Hey, write an if statement if this is true. I mean, not write an if statement. More like write an if statement that prints something if your favorite number is less than 100. And then yeah, the next one is pretty much the same stuff, right? If something, then print something. Right? If something, print something again. Oh, you know what? Number 3 might be a little tricky. I just realized it. You could skip number 3 if you want. But if you want to give it a shot. Okay, let's see. Same number 4. Yeah, we have enough to get all 5. Okay, let's take a quick 10-15 minute iteration. Intermission, I mean. Make it like 12 minutes. A little shorter. 12-minute timer. We are practicing if statements, number 1 all the way to 5. Okay, hopefully some people give it a shot. So yeah, 1 through 5 is really asking if we can do some if statements. Number 1, it says print low if your favorite number is less than 100. So we want to write a condition that represents if favorite number is less than 100, right? And don't forget this colon. This is part of the syntax. Then the body here, right, once again, make sure there's an indent. Print low. All right, so in this case, it's going to print low because my favorite number happens to be lower than 100. Right, but if I were to change it, right, what do you think is going to happen? Right, if I change it to like 200, right, I'm going to reload this. So run. This is no longer going to print low, right, because this is no longer true. All right, so people cool with this so far? All right, just some if statements. The second one is asking if you can write a condition that checks if a string is inside of another one. All right, so if this Python string is inside of course, then it should print snakes. All right, so this is like what we were showing earlier. You can use the in operator to check if things are within things. So in this case, we're just checking, if Python is contained in course. Right, this is doing a string search, right? Checking if this string is inside this string. In this case, we're just going to print snakes. And yeah, print snakes because Python is in the course, right? The course is Python programming for everyone. Okay, cool. Let's see. Number 3, this is the opposite. This is, say, print no snakes if course does not contain the word Python. There's many ways you can go about this with the limited stuff that we know so far, if statements. You'd have to do like the opposite of this right here. And you can actually do the opposite of this. I haven't talked about it yet, but there's an operator, it's called not. If I were to put a not in front of this right here, it's going to negate this condition here and then print no snakes. All right, so I know this is a little weird to read, but once again, this thing that I highlighted, this is either going to evaluate to true or false, and then this not right here will negate that. Right, negate means it's going to make it opposite. So in this case, nothing is being printed. Right, the reason why is because this is true. Right, Python is in course is true, but then this not makes it false. Right, so this whole condition ends up being false, meaning that the body will not be executed. All right, but if I were to kind of go up here and change it, let me just change this course. Right, like let's say we're in a different class. Maybe say we're taking CS-11. CS-11. This is C++ programming. I think it's called Intro to Programming in C++. I think that's what CS-11 is called. So let me reload these variables into it and test it. All right, there it goes. Brand new variables. Let's see, what's this going to print? Nothing, right? Because Python is not in the course anymore. Here, right? Let's see what this is going to print. It prints no snakes, right? The reason why is because this thing I highlighted, Python in course, right? This evaluates to false, but this not negates it, so the whole thing becomes true, meaning that we're going to execute the body. Right, so we haven't really talked about this not keyword yet, but yeah, that's pretty much what's happening. We'll talk about this later. Another way you can do this is with an else statement, which is what we're going to talk about later. So another way you can do this is by saying, oh, if Python's in course, do this, and then else do the opposite, right? Because the else branch would capture the false things, right? Like if the earlier one was false, then it's gonna land in the second branch. Right, so these are kind of the same, If anything, I'm talking about this else branch. And yeah, it prints no snakes. Once again, I did change the course name on top. I kind of just snuck this in. I changed the course name. It no longer says Python. So no snakes. Okay, let's move on. Let's see. Hold up. Attention needed. I don't see an if or not in your solution. Okay. This feedback is probably wrong. Let me check it real quick. I don't see an if or not in. That's weird. Okay, well, this is right. I think this feedback thing is giving us the wrong feedback. So yeah, don't worry about this too much. It's probably being picky. It's probably saying you want the not over here instead. And yeah, it's the same. Yeah, it's the same thing. Whoops. So I just moved the not over. It's the same behavior. But in most other languages, you'll see that the negation is outside of the condition. Okay. Cool. So number 4, this is saying if you have the same first name as the instructor, print same. So that's just comparing for strings, right? These two variables are strings that we declared in the beginning. So we just got to say if those two strings are equal. So if instructor is equal, all right, once again, don't forget the double equals first name, right? So if they're equal, then we're just going to print same. Print same. So let's test it. For my case, it's going to print. Oh, mine doesn't print the same because this wasn't true, right? So it's because the instructor was the full name. All right, so here if I were to go to the top, right, it was saying, hey, is this string equal to this string? No, they're not equal, right? Because this one has a last name. But if I were to change it, make them both Andrew, right, then it should print same because should be true now. There it is, right? Print same. For you folks, it should print nothing. Okay. Let's test that again. Let's do one more, and that should be it. So this one is saying print vote if we are of age. In this case, it wants us to do some subtraction. It wants us to calculate the age using two different integers. Earlier in the beginning, we declared two integers, current year and birth year. You can calculate your age based off this and then determine what to do. So it says use the current year and birth year to calculate your age. Let's go ahead and do that. All right, I'll do it in a separate variable. I'll just say, create a new variable named age, which is equal to current year minus birth year. Right, so age becomes a number. In my case, age will become 29. And then we're going to branch based off age. I mean, not branch. We're going to make a fork, right? If our age is greater than 18, right, then print vote. So for my case, it's going to print vote because I am of age. But if my age was different, it's not going to happen, right? Yeah, I think folks are getting the point here. Okay. Let's see what's happening here. It looks like the feedback is tripping again. I saw vote when I shouldn't have. Greater than or equal to 18. Maybe it has to be greater than or equal to. I might be off by 1. So yeah, it should have been equal to. Okay, there it is. That was my bad. So I actually had an off by 1 error there. If folks were curious, earlier I had the condition as age is greater than 18, but you can still vote if you are 18. So you got to get this equal sign, right? Greater than or equal to. Okay, there we go. People cool with this so far? Okay. So to summarize what we did so far, all we talked about was the if statement. This is a fork in the road, right? It's not really a tree yet. We're going to talk about trees now, though. All right, we're going to introduce some control flow. In particular, the else statement. Hold up, let me think about something real quick. I feel like I skipped over something. Let me think. Yeah, I didn't skip over anything yet. All right, so let's introduce the else statement. Going back to the lesson. Okay, so scrolling down to this section, if with else. All right, we're finally going to create a tree with 2 branches. Right, that's kind of what the if with the else looks like, right? If the condition is true, we'll go into this scenario. If the condition is false, we're going to go into the else branch. So that's kind of what we're going to talk about now. All right. So yeah, the syntax is the same, right? If some condition, then we'd do the colon here and in the body. The else is a little different. The else doesn't really take a condition. You see how it just says else and then colon. Right? You don't need any condition, but the reason why is because syntactically, right? If this is false, if the first one is false, then we're just gonna go into the else branch anyways. So you don't really need a condition for this. All right, so let's go ahead and keep playing with the guessing game widget that we did earlier. All right, at the beginning of the notebook, we had a number widget, which looks like this right here. So this number widget is giving us a box to type in a variable, and we're gonna branch based off this value. Okay, and we started off with just one fork in the road. Right, so scrolling up, we ended off with just a single if statement. All right, so I'm gonna copy this. If is equal to 34. All right, this is where we left off at. If equal to 34, print correct. All right, in this case, it's not equal to 34 because the number widget is 50. But if I were to change this to 34 and rerun this bottom cell, it's gonna print correct, right? Because I got it right. Let's go ahead and do the else statement, meaning the opposite of the first one. So if we do an else, this means that if the first one is false, we're going to end up in this branch. And this branch is the incorrect branch. All right, incorrect. Try again. All right, so let's run this, and you see it says correct because the first one is true. But if I were to change this number, like maybe 50, right, 50. Rerun this cell, it says incorrect, try again. All right, hopefully this makes sense so far. All right, this first one is false, so we do the else statement. People cool with that? Whatever's in the else body is only run if the earlier condition was false. Okay, any questions about this so far? Okay. Cool, so that's the if and else. All right, we have 2 branches. Okay. This is gonna get a little trickier from here, by the way. Let me look at the lab real quick to see if there's anything we can do. Let me look at the lab. We do have enough to get number 6 done. Here, I'll help folks do this one real quick. If you gave number 6 a shot, nice job. Number 6 is asking if we could do an if with an else statement. All right, it says, hey, print yes if your name starts with L, and then print no otherwise. All right, otherwise means else. So there's multiple ways you could do this. There's multiple ways you can check for the first letter. I'll pull up the REPL real quick. Right, the classic way you can do it is by using something called string indexing. So let me pull Python REPL, type in Python. All right, there's something called string indexing. Like let me say name is equal to Andrew. All right, so name is a string. You can index into a string, just like a list. All right, so you know how lists you can use the square brackets. You can do the same with strings. Right, if I were to put 0 in this square bracket, it's gonna give me a, right? Because this is the character at the first element. If I said name 1, this evaluates to n, and so on, right? To all the way to the length minus 1. Length minus 1 is 0, 1, 2, 3, 4, 5. So 5 is the last element. All right, so you could use this if you wanted to. This lab is saying, hey, print yes if your name starts with the letter L. So we could do that, right? If our name starts with the letter L, right? So you could say, oh, if the first element is equal to L, then print yes. And then else otherwise, right? Else print no, I mean. Okay, so for me, my name starts with A, so it prints no. Right, but if I were to change this condition to like A right here, if first name is equal to A, it should print yes. All right, this making sense to folks? I change it to an L, prints no. Cool with this. All right. Cool. Let's just jump back to the lesson. Okay, so I just jumped back to the lesson. Let's move on to the tricky part of the lesson. This is definitely trickier because we're going to talk about something called elif. This is the part where we're going to end up with branches on the same layer. Right, so we'll have an if and else, which are two branches, but it's possible to have multiple ones in the middle as well. And this is with else ifs, I mean. In Python, they call them elif. Right? Elif gives another branch on that same layer. And in this case, it's this else one. The last one would be the the fallback case. Right? If all of the earlier ones was false, it's going to end up in the last one, the red. Okay, so let's talk about the elif. Okay. Back to the guessing game. It might be useful to give them multiple hints. Like maybe you could tell the user if they're close, right? Like, oh, you're too low, or maybe your number is too high. All right, so let's go ahead and give them some hints. So here's the number widget. Right, our current solution so far is right here. I'm gonna paste it. So from earlier, right? This is our earlier solution. Right, maybe we want to give them some hints, like 50. Right, 50 is too high, so maybe the program should have a branch that's too high. If we said like, negative 20, this is too low. So let's go ahead and program those branches, because currently we only have correct and incorrect. So instead of this else branch, right, we could replace it with an elif, which takes a condition, by the way. It takes a condition. So in this case, the condition would represent the hints, right? Like if they're too low, all right, so if they're less than 34, then it's too low. Too low. And then I'm gonna do another one. This one's gonna be an else. Right, an else doesn't take a condition, and it only happens if the earlier two were false. So you don't really need to make this an else if, right? You could use an else if for this last one, but you technically don't need it, right? Because if these first were false, then it's probably guaranteed that it's too high. You know what I mean? Logically, like. If I were to go, if I were to do like 100 right here, right? This is too high. So let's see what what might happen, right? 100. Is this true? No, it's not. So we're gonna check this next branch. Is this true? No, 100 is not less than 34. So it's gonna end up in this fallback branch, right? The last resort. So it should print too high. Now, once again, you could make it an else if, right? You could say else if number widget is greater than 34, right? This is logically the same, right? But you don't really need to specify this. So this still prints too high. All right, let me change it back to an else though. Okay, so there's an else. All right, let's keep playing around with this so people can kind of see what's going on. All right, let me choose -20. All right, -20. Let's trace. So is this true? No, it's not. So we're gonna check the next branch. Is this true? Yeah, it is. So we're gonna print too low, and there it is. Right, prints too low. Right, this it doesn't land in the last resort branch. All right, people cool with this so far? So this tree represents this diagram right over here. All right, any questions about this? Okay, I want to point out some common pitfalls and things that might seem weird. It's a common pitfall to accidentally disconnect the tree. Currently, this is a tree with 3 branches. It's possible to accidentally disconnect them. Here's what I mean. All right, what do you think would happen if I change this middle branch to an if only? So check it out. I'm going to remove this. I'm going to remove this, meaning that it says if this, right? And then if it's too low, print too low, else too high. All right, what do you think is going to happen? All right, let's see. Let's think about it. So I'm going to make it -20, right? The number is -20. So let's trace through it. Is this true? No, it's not. So we're not going to do this. All right, is this true? Yeah, it is true. So I'm going to play it. It prints too low. Perfect, perfect. This looks like it's working. All right, let's test another branch. Like let's test 100, right? Or 1,000. It doesn't matter. All right, it should print too high. Let's predict though, right? Before I press play, is this true? 100 great equal? Nope, it's not. Is this true? No. So it must land in the else branch, right? So there it is, right? It prints too high. Cool. So it's looking like it's working, but there's actually a logical error here. Right? Can people kind of see it? It's kind of hard to see. It's kind of hard to see. There's a logical error. For example, if I made this 34, right? If I guessed the correct number, let's see what will happen. So I made it 34, right? This should be correct, right? It should print correct, and hopefully it doesn't print these. But check it out. I press play, and we get 2 print statements. All right, people see what's happening here. So scrolling up a bit, right? We chose the correct number, but why did it give us 2? Why did it say too high when it shouldn't have? Not a little weird? Right, our first print statement is correct. Right, we did get the number right, but what's happening here? So what's happening is we accidentally disconnected the tree by making this second branch an if statement. Technically, this program now has 2 trees. Right, so I'm gonna put some new lines in here to make it more readable. Technically, we have 2 trees here, or not really a tree. We have a fork in the road, and then a tree down here. All right, so what's happening is, our number is correct. Right, so this first one does happen, right? 34 is equal to 34. So we print this, but they're disconnected, right? This is a fork in the road, right? Meaning that when we finish this, we're gonna go check this statement out now, right? Is this statement true? Right? No, it's not. So since it's not true, it's gonna end up in this fallback branch and print too high as well. Right, people kind of seeing the logical error. Here, let me draw this out so people see what's happening here. I'm gonna draw this out real quick. Um, you know, to make this a little easier to read, I'm gonna stop using the widget. All right, here, let me just let me stop using the widget because I'm getting tired of scrolling up and down. I'm just gonna use like a number, make it like 34. Make it equal to 34, right? I just erased the widget stuff, make it a little easier to read, and it's gonna give us the same thing, right? See, number 34, it still does the same thing. All right. So what's happening? Right, this shouldn't happen. Let me draw out what's happening. So this first if statement, this is it's a what's it called? A fork in the road. So let me draw this out here. All right, this if statement is representing this fork. All right, it happened to be true, so it took this green arrow and printed correct. All right, so it printed correct here. But then this over here represents a tree of 2 branches, right? The if with the else. So it's looking like this over here. Right? This is what the tree looks like, right? If and else. So this tree is connected to the fork in the road over here. All right, so yeah, do people see how this diagram is related to this code right here? Right, number is equal to 34, so we do go down this green, right, and then it's a fork in the road, meaning that now we're checking if it's less than 34 or not. All right, so people see the logical error here, right? We accidentally disconnected the tree. So yeah, this is a big takeaway. This is a really big takeaway. If anything, the takeaway here is if you use 2 if statements next to each other, they are technically disconnected. Right? So even though they're like right next to each other, they're still disconnected. So yeah, people see what I mean with this diagram, right? The logical correct way is to combine the tree into a single layer, right? And the way we do that is by using an else if for the middle. Okay, so let me go ahead and fix that. Okay, so let me make this an else. Right, and now we have a tree, a single tree with 3 branches, meaning that it's only going to print 1. All right, I'll press play. There it is, right? It prints correct. Right, and if number was something else, like 50, right, it's still gonna give us the correct behavior. See, 50 prints too high, right? Because this didn't happen, this didn't happen, so it ended up on the fallback. All right, people cool with this stuff so far? It's a pretty big takeaway. I'll repeat this again on Thursday with a different scenario. Okay, so yeah, you can read this stuff later. These are the syntactical rules that Python uses for these branches. Basically, whenever you have a tree or a fork, you would always start it with an if statement, and then the else if. These are optional, but you can have as many as you'd like. You can, and finally the else. This is like the fallback, right? If all of the earlier ones were false, then we're going to end up in the last resort. Right, so the last resort is right here. Right, you don't need a condition for it because it's the last resort. Okay. Any questions about this so far? All right. Cool, cool. Let's add one more branch. Maybe. So here's our current tree so far. Let's go ahead and add another branch that tells the user they were way too off. Like maybe, let me go ahead and get it ready. So press play. We're dealing with a number widget again. So I'm actually gonna convert this. Here's our current program. Let me change it back to the number widget's value. So number widget.value. All right, this way we're branching off whatever this widget is. Okay, let's add another branch that tells them, oh, they're way too off, right? Like maybe if they typed in like 1,000, like 10,000, right? Maybe you could say, oh, that is way off. Try again, right? And it's the same with like negative like 6 million or something, right? This is way too off. So, let's make some more branches. So you could do another else if branch, right? You could do another else if branch that represents, oh, they're way too off, right? Like maybe you could say else if they are far away, right? Like you could define far away however you want. For me, I'm just gonna keep it simple and say they're greater than 100. All right, we can say if the number is greater than 100, they're way too off. And then I'm gonna introduce something called an OR. An OR is an operator that kind of combines booleans. So here, let's talk about the OR is. I'm gonna put another condition in here. Let's see. I'll say or their number is way too small. And here I'm just gonna say is less than 0. Then print you're way off. Way off. All right, so I know I introduced this or right here, but in English, are people able to kind of read this? Like, are people able to see what this logic means? Right, this is saying if the number is greater than 100, or if the number is negative, then we are printing way off. All right, so people see what the or means, right? It's combining two conditions together. All right, so this is condition 1, this is condition 2, or you can put parentheses around it if you want. It makes it a little readable, but it's not necessary. Right? It's a little more readable now. But yeah, with an or statement, only one condition has to be true in order for the whole thing to be true. So in this case, if I were to use like 200, right, this is gonna print way off. So I'll press play here, right? See, it prints way off. The reason is because, wait, what happened to here? I thought I changed the number. Okay, well, anyways, the number is negative 5 million something. So is this true? Is this first branch true? No, it's not. Okay, so we're gonna jump into the next one. Okay, so the next one, this is a chained condition. We're gonna check the first one. Is this true? No, it's not. Right, the value is not greater than 100. So we'll check this one. Is this negative? Right, is the value less than 0? Yeah, it is. So since this is true, the whole condition is true because of the or, meaning that's going to print way off. Okay, and once again, these are chained. Right, this is a branch. This is a tree with 4 branches, which guarantees that only one of them will happen. And in this case, it's this one because it's the earlier one. Right, you can keep testing too. Right, so let's say like 200. Right, 200 prints way off still. All right, let's try out more numbers like maybe 20. All right, 20 prints too low. All right, hopefully that makes sense because everything was false up until this third branch. All right, people cool with this? Okay. Cool. Any questions about this so far? Okay, cool. I want to point out another pitfall that may happen. This pitfall relies on the orders of a condition. What do you think would happen if I were to change the order of the middle 2 else ifs? All right, what do you think would happen? Well, here, let's test it. All right, it's always good to predict before testing, right? Because mistakes can be expensive sometimes. So, usually you want to kind of sanity check things before you press play, right? Okay. Let's predict what's gonna happen before we press play. So 20. Okay, let's trace. Is this true? No. Is this true? Yes, it is. So it should print too low. All right. So it prints too low. There it is. I just pressed play. All right, prints too low. Cool, that makes sense. But you want a sanity check with a bunch of numbers. Like if I were to say, you know, negative 2000, right? Our goal is that this should print way off, right? This way it can tell the user some hints. But what's going to happen here? All right, what's going to happen? All right, is this true? No, it's not. Is this true? Yeah, it is. So it's going to print too low. All right, there it is. I just refreshed it, or just press play. It does print too low, which is technically right, but it might be more correct if it said way off, right? Because we want to give a more accurate hint. So the pitfall here is the ordering of the conditions, right? The ordering here, if an earlier one is true, the next ones won't be checked at all. So does that make sense? See, because this is a tree with 4 branches. All right, it's not really forks in the road. So when we find out that this one is true, the program says, okay, there's no need to check the next ones. So it's just going to print this, and that's it. And it's going to continue on with the rest of the program. All right, so yeah, people cool with this, right? This is technically right, but not fully right. So the pitfall here is ordering. Typically, you want to have the stricter condition first, right? This is technically the stricter condition, so it might be more appropriate to check the strict stuff early. All right, so in this case, this would give us more correct one, way off, right? Negative 2000 is way off. Okay, people cool with this? Tricky stuff, right? Tricky stuff. Okay. Okay. Cool. Let's see. This is it for the notebook. This notebook is really just introducing if statements, else ifs, and the else. There's going to be some logic down here as well. We talked about logic actually already. In particular, logic here means combining different booleans. Like you might have seen some truth tables before in the past. If you ever taken like a philosophy class, you might have seen some truth tables. So let me just pull up some Boolean truth tables. Stuff like this right here. Let me pull it up. So this is a little conceptual. Let me pull this image here. All right, so looking at this or in the third one, right? We talked about or, meaning that both x and y, right? Only one of them has to be true in order for the whole thing to be true. Don't worry about this plus sign right here. This is just Boolean algebra. But this is, right here, the second column, this is saying false or true. This evaluates to true, right? True or false, this evaluates to true because one side of it is true. Right, so that's what I mean by logic. It's combining operations, combining Boolean expressions. All right, so here let me do an example of a Boolean expression. Right, like let's say I'm gonna pull up the REPL again. So load up a terminal. I'm gonna type in Python, and then just kind of play around with some single liners. Let's see. Let's say age. Let me just hard code age to like 29. All right, I'm just hard coding an integer variable. All right, we could say, hey, is age less than 30? Is age less than 30? Yes, it is. But what about this? Is age less than 30 or age is greater than 100? All right, what do you think is going to happen here? right? We'll treat these as two separate conditions, right? It only takes one condition for the whole thing to be true. In this case, the first condition is true, so the whole thing becomes true, right? Cool this so far. Okay, and let's change it up a bit, right? So our age is still 29. Let's change it up. Let's say maybe age is age is less than 50. Wait, no. Let's do this. Age is, yeah. Let me just say age is less than 50, and right. So this is a different Boolean logical thing. So and age is greater than 30. Right. So with the and, both sides must be true in order for the whole thing to be true. Right. So is this true? Is age less than 50? Yes, it is. Okay. Is this true? Is 29 greater than 30? No. Right, so immediately the whole thing is false. Right, does that kind of make sense? Right, this condition is checking if our age is within a certain range. Right, so people kind of getting a sense on the what ors and ands are, right? The difference, what this truth table kind of represents. Right, to bring it a little more simple, you can, to simplify things a bit, right? You can say this right here, like the truth table is pretty much saying false or false, right? So these are Boolean literals. This evaluates to false, right? Because both sides are false, right? But then if I said true or false, this evaluates to true, right? If I said false or true, this evaluates to true, because the right one is true. Right, if I said true or true, this is still going to be true because both of them are. So yeah, people kind of seeing what these truth tables are representing, right? In this case, x and y, you can imagine these as variables that come from a Boolean condition. Okay, any questions about logic so far? Right. We have a lot of tools now. We can now write more complex programs. Okay. Cool. Yeah, folks can read this stuff later. Okay. Let's see. Let me look at the lab real quick. Okay, we have enough to get pretty much the rest of the lab done, actually. Yeah, we do. We ended off on number 7. Let's go ahead and take another intermission, like maybe a little longer one. But let's see if folks can do the rest of the lab. Actually, no, not the rest of the lab, but you should be able to do number 7 and 8 at least. All right, number 7, this is asking if you can do a if and else statement. And then number 8 is asking if you can do ifs with else ifs to determine what generation you land in. Yeah, so yeah, go ahead and give it a shot. You can get number 7 and 8 done, and maybe part 3 on functions. But you don't have to do this. Maybe at home you could. But yeah, let's take a break. Intermission, I mean. I'll give this 12 minutes again. It's only 2 questions. You should do 7 and 8. 12-minute timer. All right. Yeah, go ahead and give it a shot, folks. Okay, cool. Let's go ahead and try out these 7 and 8. So number 7 is asking if we can write 2 branches. Oh wait, no, it's 3 branches. My bad. It's saying, hey, write a branch for millennial if our birth year is within a certain range, and then 2 other branches, right? Older if we're not within it, and then younger if we're also not within it, depending on your birth year. So let's do the most restrictive branch first. There's many ways you can represent this, by the way. I'm probably going to go through like 2 different ways. But yeah, one way that most people might have done is check the first one, right? The most restrictive branch is if our birth year, right, is between these 2 numbers. How do we represent that? Well, one way is by representing 2 conditions. Right, we can say if the birth year is greater than the lower bound and less than this upper bound, then we are a millennial. Right, so you could do that, right? You could say if our birth year is greater than 1981 and the birth year is less than, oh, we need to include these years, my bad. This means that there needs to be an equal sign. So birth year is also less than or equal to 1996. I see these are 2 separate conditions. Right? A pitfall might be someone might omit the second variable right here, which is, I think, a syntax error. You know, in English this does read, but I don't think Python would treat this well. It's saying if birth year is greater than 1981 and less than 1996. This is technically a syntax error, I think. You could try running it, but it's probably going to complain that this is technically not a condition. But when we put a variable to the left of it, right, this is now a condition. So if we're within that range, we can print millennial. All right, let me test it real quick. Yeah, for me it prints millennial because I'm born in 1996. Let's go ahead and get the other branches. Like print older if you are older. All right, so yeah, we could, how are you gonna do this? Let's see, you can use else ifs, you could use ifs. There's actually many approaches you can do. It doesn't matter. In this case, you could say else if. You could say else if we're older, right? So if we're older, then that means our birth year is less than 1981. Then this is older, right? And then we could do the opposite of this branch. We could say else if birth year is greater than 1996, then we are younger. I see. For me, it still prints millennial because the first one is true, so it doesn't bother checking the next ones. Okay, let me test all 3 branches. Actually, it's a good idea to test all outcomes before you kind of like publish things. So let me test all outcomes. I'm gonna hard code birth year. I'm gonna overwrite it and make it like a different number. Let's make it like 2000. All right, so 2000, and this means that you're younger than millennial. So I'll press play, and yeah, see, it prints younger because this first one is false. Right? Do you know why this first one is false? Well, you know, this. What about this? Is this true? Is birth year greater than 1981? Yeah, it is. Right, but there's an and here. Right? It's saying and we're also less than 1996. Right? This ends up being false. So once again, with an and, this whole thing becomes false because the right side was false. So we're gonna jump into the next branch, right? Is this true? No, it's not. Is this true? Yeah. So there we go, prints younger. People cool with this so far? Okay, great. So the diagram is right here, right? This is what we just coded, right? A tree with 3 branches. It's technically possible to make them like 3 separate forks in the road. Like right here, you can actually disconnect them and make them all if statements, and it'll probably give you the same result. All right, so I'm going to disconnect the tree, meaning I'm going to convert them all to if statements. Right, there it is. I disconnected it. They're all if statements, meaning that we're representing this diagram right here. Let me zoom in. All right, basically when we chain if statements, it's technically not a tree with 3 branches. It's 3 separate forks in the road. All right, this is still probably going to give us the same result. Let's test it, right? See, let's test this. 2000, this still prints younger, right? The reason why is because this is false, and this is true. All right, let's test it with more, like 1996. This is true, right? That makes sense. This is false, this is false. Cool, yeah, this makes sense. If anything, this is actually kind of inefficient. You don't really see it. This is inefficient because there are conditions being checked when they shouldn't be checked. For example, this first branch is true, right? 1996 is within this range. This is true, so we're gonna print this. But then Python will check the rest of these branches when it doesn't need to. Right? It's gonna say, okay, is this true now? Right? No, it's not. Okay, now it's gonna check this last one. Is this true? No, it's not. So it's inefficient because we're doing redundant checks. Right? It might not seem like it makes a difference because it's instant response, but when you move on to more complex programs that need to perform fast, you know, these extra conditions can take a toll on the program. Right? Basically, when you start looping programs and run them over and over again, right, you can have a bottleneck over here. So if we were to connect them, it would be a little more efficient, right? By connecting, I mean no forks in the road, right? So kind of combine all of these forks into a single tree, right? That's what I mean by combining. And the way we do that is by making them else ifs. Right, so I made an else if here. All right, this is going to give us the same result, but it's more efficient. The reason why is because since we connected the tree, the next ones won't be checked if an earlier one is true. So in this case, the first one is true, but since it's a connected tree, the next conditions will be totally ignored. Right, we're not even going to bother checking these over here. Does that kind of make sense? Right, so this is efficient because if the earlier one is true, it's not going to check the next one. So this is a big takeaway. The big takeaway here is the difference between a connected tree and a disconnected one. Right, this is not really a tree. It's really just 3 separate forks in the road. Right, it's totally different behavior. It just happens that we have the same behavior here. Okay, any questions about this? Oh, okay. I just asked for feedback right here, and it looks like I got it wrong. Let's see what happened to here. Let's see. It says birth year of 1981 should be millennial. What did I get wrong here? Birth year of 19. Well, let's test it. We test 1981. So this should print millennial. Oh, it does print millennial. Okay. I think this feedback cell might be acting up. It might not be right. Okay. Oh, you know what? It's just a spelling error. It's crazy. I'm sure folks have experienced this before. I spelled millennial wrong. So yeah, this feedback is right, actually. It is right. It says, I just spelled millennial wrong. It needs 2 N's. So Run this, and there we go. It's just a spelling error. Logically, we were still right. Okay, let's move on to one more, and I'll let folks try out the rest. This is a little trickier. Let's see. Okay, this one is asking to program the other generations, like baby boomers, Generation X, millennials, Generation Z. Right, these are like nicknames for certain ages of people. So yeah, you can do this however you want. There's so many different approaches, right? The one approach you might take is maybe a branch, maybe a tree with 4 branches. Right, so you could set up the skeleton of this. Right, you could set it up like a tree with 4 branches. Right, so right away it's like a if something, right? If something, else if something. Whoops, hold up. So the auto indent did something incorrect here. It should not have indented. And actually, if you indent it, this now belongs in this first branch. So you don't really want to do that because that's called nesting. So let's see, boom, else if something. Right, so you can imagine that the tree would look like this, and then in each of these it would print something else. All right, print baby boomers for this right here, and then maybe this one would print Generation X, and this one would print something, and this would print something. Let me change it. So this should print Generation X. This should print millennials. And then this should print Generation Z. Okay. Cool. Yeah, people kind of seeing what I mean here, right? These somethings should be conditions. So what condition do we need to represent the baby boomers? All right, well, we just need to represent that the birth year is between these ranges. All right, so we could say if birth year is greater than equal to 1946 and birth year is less than equal to 1964, then print baby boomers. All right, let me just test this real quick. So, you know, before you program the other branches, it's a good idea to test the outcomes along the way. So I'm actually just gonna hard code a birth year. I'm gonna overwrite it. Right, we do have birth year. You know, it's initialized in the very beginning, but I'm overwriting it so I can test each outcome. So I'm just gonna say birth year is equal to 1950. 1950. Hopefully this prints baby boomers. And yeah, cool. It prints baby boomers. Perfect. Let's get the let's keep testing. So if we were in 1965, it should print Generation X, but it's not going to print it yet because we didn't get that branch. So let's get that branch in. All right, Generation X. We want to represent the other birth year. So let me see. This is 1965 to 1980. And birth year is less than 1980. Generation X. Let me test it. Perfect. Prints Generation X. And then let's get the rest of these in. Millennials, 1981 to 1966. Okay, 1996. And let me test this. Let me change birth year to 1996. And hopefully it prints millennials. Perfect, perfect. And finally, Generation Z. Uncomment this. This condition needs to say if we're between 1997 and 2012. So birth year is greater than equal to 1997, 2012, then generation Z. So let's test this. Let's see. So birth year of 2000 should be a Gen Z. There it is, right? Gen Z, perfect. And yeah, this looks good. You know, this last one might seem like it's redundant. Yeah, you know how the last branch can technically be an else? Like, you don't need this condition. Well, you do. Right? If you made this last one an else, it's a fallback. It's a fallback branch, meaning that this is going to happen if all of the earlier ones were false. Right? So this is going to give us the same behavior, but it might be more appropriate to specify the range here, because if a birth year was like 1900, right? So 1900, what's going to happen? All right, what do you think is going to print? It prints Gen Z, right? And if you're from 1900, then you're probably not Gen Z. So hopefully people see why we need to specify the condition here, right? We need to say else if the whoops, I accidentally undid my changes. So we need to change it to else if birth year is 1997, 2012, and now none of these should print, right? None of them should print because none of them are true. So yeah, people cool with this so far? Okay, cool. All right. So that's about it for part one. By now, make sure folks are okay with all of these diagrams here. Right, just kind of reviewing what we did. In if statement, this is the fork in the road. This is the first thing we saw. You can combine multiple if statements, but these are separate forks in the road. So it's not really a tree. All right, but then later on we talked about if and an else, which is a fork on the same layer. And then we talked about more layers, more forks, and this is the else ifs. Right, these are kind of in the middle of them. So the else if would go here, and then the last resort would go at the else. All right, so by now people should be kind of familiar with these diagrams. If anything, I'm gonna let folks try out the rest of this lab. It is some good practice here. The rest of this lab is in part 3. Pretty much you're gonna be writing functions that do if statements. So I'll pretend like they exist and help folks set up with the test cases. So you'll see kind of how to start. Right, in number 1, this is asking you to write a function that converts a year into a string. Meaning that, assuming it exists, right, so to test my function down here, hold up, I can't even edit this cell. If you can't edit this cell, once again, you can click on the top right, make it editable, and now you can edit it. So imagine that this function exists. Right, so the function is called get generation. Okay, and it takes a integer argument, a year, meaning that if I were to pass in like 1996 right here, right, this is the integer, the function should evaluate to a string. Right, so if I were to, it should evaluate to the string millennial, I believe, because 1996 is a millennial. Yeah, it should print millennial. So let me document this. Right, this evaluates to millennial, meaning if we print it, right, it should print millennial. Right, and then if you were to invoke it again, right, invoke it again, generation Let's say 2000, right? 2000 is Gen Z, I believe. Yeah, yeah. So 2000. This should evaluate to Gen Z. If we printed it, it should print Gen Z, and yeah, so on, right? You can test more and more, like baby boomers and Generation X. Hopefully people are seeing the point of this function, right? You define it up here. The function would take that year and branch based off of it, and depending on what it is, it's going to return a different value. So it's possible that your function will have branches that return different values. Okay. This next one, number 2, it's pretty much the same thing. It's asking you to convert a number to a string again. Right? In particular, the number is like a percentage, and then the string would be some letter. For example, assuming that the thing does exist. Oh, I gotta edit this cell again. Assuming that the function does exist, percent, right, would give it a percentage, like maybe 98%. 98% should evaluate to A, the string A. So if we print it, right, it should print A. Right, and same with the other grades, right? Like if we were to invoke the function with 85, this should print B, right? And so on. Right, you should program all the branches. People cool with this? You seen the goal of this function? Right, basically this number would go to the function, and then the function would branch based off of that value, and then based off the value, it's going to return different numbers. I mean letters. Right, like if the number is within a certain range, then return A. If it's within a certain range, return B, and so on. Yeah, so go ahead and try that out. The last one is really the same thing, but it's a little harder. It's really asking if you can add the plus sign, right? Like, some colleges, they care about the plus, like A plus, A minus. So this function is the same, but it's just adding some more complexity. So you could try this out. But if you can do the first 3, that would be great. The generation and the letter grade. First 2, I mean. Yeah, so go ahead and give these a shot, and I'll go over some sample solutions on Thursday. Right, there's a lot of different ways. I would like folks to try this out first, just because there's so many different ways you can go about this. Okay, so let's see. We're at the time. Perfect timing. Let's see. We're 1 minute away. So here, let's summarize what we did so far. We finished talking about logic and decisions. In my opinion, we need to spend another day on this, right? Even though we finished the lesson in the lab, we probably still need to spend another day. So on Thursday, I'm gonna do like a large example, like a large program that kind of makes different decisions, and then we'll finish the rest of the lab and give a sneak peek into the next project. The next project is called Calculator. It's pretty much asking if you can write a bunch of if statements to program a calculator. Okay, that's about it for today, folks. Thank you all, and have a great night. Bye-bye.